Hello everyone, welcome to BHARGAV SUBS. So in today's class, let us discuss the theorem regarding theorem in electrodynamics, one of the most important theorem. It was Poynting Theorem. So what is the Poynting Theorem? Okay, so what is the basic statement regarding Poynting Theorem and what is the proof for it? Okay, let us discuss now Poynting Theorem. So Poynting Theorem. So in Poynting Theorem, what it says, it says regarding energy or power, correct? If you take a certain material or anything, if you transfer the electromagnetic wave through it, then there will be a energy before only there is a energy stored in that material. After entering the electromagnetic wave, the energy stored in the device will decrease and there is some energy flowed out of the material through its surface area, correct? So either if you take optical fiber, in case of optical fiber also, how the power was transmitting, how the power was coming out, how much efficiently the power was working in the optical fiber, and also it mainly explained us in the MR scanners, antennas, mainly antennas also. In communication system you use the antennas. So in antennas also, how much power it was radiating, how much power is coming out of the antennas. So in many ways this Poynting Theorem was helpful. Correct. So let us discuss the basic statement regarding the Poynting Theorem. What was the Poynting Theorem? Work done by the electromagnetic force on a charge, correct? Work done on the charge. If you take in any material, there was contains a group of charges. So work done on the charge by what force? EM force, electromagnetic force, by the electromagnetic force is equal to the now what it happens when electromagnetic force enter into the field, it was hit the charge. So due to that electromagnetic force hitting on the charge, there was a decrease in the energy, is equal to the decrease in the energy in the field, and this also equals to the decrease in energy in the field, and this also equal to the energy flowing out, energy flowed out through the surface. Energy flowed out through the surface. Surface means like dA, okay, area, surface area. This was like energy flowed out through the surface, also known as energy flux. How much energy was per unit time, how much energy was transmitting outside the surface. This also known as energy flux. So this is the Poynting Theorem. Work done on the charge by electromagnetic force is equal to the decrease in energy in the field and energy flowed out through the surface. This was regarding Poynting Theorem. Now let us discuss the statement regarding the Poynting Theorem. So what it happens? Work done on the charge by the electromagnetic force, dW by dt is equal to what? Decrease in energy. Decrease means negative, no? So negative energy stored in the field. So energy stored in field means it's due to many components. Okay, there was some components in the field, either maybe conductor or capacitor, inductor, resistor, anything. Like there was some materials. So in that energy was stored. What is the formula for capacitor? Half CV square. What is the energy stored in the inductor? Half Li square. So these are the formulas for energy stored. So this there is a decrease in this energy. So I can write minus half volume integral epsilon naught E square plus 1 by mu naught B square into d tau minus again. So this was the energy stored and energy flown out through the surface. Okay, so through the surface means surface integral 1 by mu naught surface integral E bar cross B bar into dA. It was flowed out through the surface, no? So dA. So 1 by mu naught surface integral E bar cross B bar dA 1 minus 1 by 2. It was like minus 1 by 2 rho by rho t. So minus 1 by 2 rho by rho t in volume integral epsilon naught E square. This was the energy stored in the capacitor. It was decreased, and also this was the energy flowing out of the surface. Like you are summing these both. So this is equal to the work done. This is the statement. This is the statement regarding the Poynting theorem. Now let us prove this. Let us prove this. How I am proving? Now I am considering a electromagnetic wave. The electromagnetic wave was traveling. This was EM wave. Electromagnetic wave traveling, and I am considering a volume. Okay. I am considering as volume V, and there are charges present inside. When the electromagnetic wave hits this, so the charge will traverse, for suppose, through distance dl. Okay, distance dl. Now what I am writing? So electromagnetic wave does work, or wait, does force F on the charge, or wait, before that what we are considering? A certain volume, no? So we have considered a certain volume now. So consider an elementary volume V with surface area A. So I consider. Now what I am doing? I am making to transfer electromagnetic wave through this. So electromagnetic wave applied force F on the charge such that it moves with velocity v through distance dl. Okay, through distance dl. Now what I can write? Application of force F and with velocity v through distance dl. Now what I can write? Then work done. What is the work done? dw. What is the work done formula? Force into displacement. Force into the distance traveled through the charge. What is the force here? F dl. Okay, F dot dl, and this is the F dot dl, and this was like equation 1. Okay, again I want force and dl. What is the force? Force F is equal to total force applied by the electric field and electric force and magnetic force. Okay, generally we will consider like total force applied by both fields. So on charge q, force on due to electric force and force due to magnetic force, V bar cross B bar. This is also known as Lorentz force. Okay, this is also known as Lorentz force. Correct? Okay, this was force 2. And what is the dl? Distance. What is the distance formula? Speed into time. What is the speed here with velocity v? What is the time? In time dt. Okay, so distance dl is equal to speed v into time dt. So dl is equal to v into dt. So this was equation 3. Now what I am doing? I have to substitute this force and distance in the place of force and distance. Okay, I have to find work done. Correct? So let us find the work done. So this equation 2 and 3 should be substituted in 1. So let us substitute that. 2 and 3 in 1. 2 and 3 in 1. After substituting, what I will get? dW, no? So dW is equal to F bar dot dl. What is F? Q into E bar plus V bar cross B bar into dl. What is dl? V into dt. But there is no application of force due to the magnetic field. Correct. So there is no application of force due to magnetic field. So this will be equal to 0. So V bar cross B bar is equal to 0. Then what is dW? Q E bar V dt. Correct. Q E. So dW is equal to Q E bar V dt. This was equation 4. Yeah. Up to now you understood, no? I find work done. So like we got work done is equal to Q E bar V dt, no? So like fourth equation. Now we have to apply the formula for charge density. Means you got V. So like you got Q here. So you have to find the Q value. What to substitute in the place of Q? Correct. So in the place of Q, I want so applying the formula of charge density. So what is the charge density formula? You know, like Q is equal to rho into d tau. And in place of rho, you can write J is equal to rho into volume. So rho is equal to J by volume. So you will substitute here. Correct. So like this was charge density. Rho is equal to J by V, no? J by V d tau. So I can this was 5. Substitute 5 in 4. 5 in 4. So then what I will get? dW is equal to what is the formula? Q E bar V dt. So in place of Q I will substitute this J by V d tau V dt. So V get cancelled. Now what I will get? J d tau dt dW. Okay, let us keep aside now. So this is sixth equation. Now I have to consider now Ampere law. So what is Ampere law? So what is the equation regarding Ampere law? So considering Ampere law, which was the cross B is equal to mu naught J plus mu naught epsilon naught rho E by rho T. This was the Ampere law. Correct. This was the Ampere law. So now what I am doing? I want J because I have to substitute here J. So I want to find this J value. So mu naught J is equal to del cross B minus mu naught epsilon naught rho E by rho T. So I want to find J. So for J I will transfer this mu naught to this side. So 1 by mu naught del cross B minus here 1 by mu naught into mu naught epsilon naught rho E by rho T. So mu naught get cancelled. So finally I will get J bar is equal to 1 by mu naught del cross B minus epsilon naught rho E by rho T. And here see here E also there, no? V will get cancelled. Why we missed the E? So E into V d tau dt. This was d tau. Okay, d by v d tau. So this v get cancelled. So here E also there. Correct? E into d tau dt. Okay, this was the statement 6. So I want JE. Okay, so I will multiply this equation with JE. Okay, so here if I multiply with JE, so J bar dot E bar is equal to 1 by mu naught E bar dot del cross B bar minus E bar dot epsilon naught rho E by rho T. Okay, this was the equation 7. Okay, I want to find this JE value, J bar dot E bar, J bar dot E bar. So J bar dot E bar is equal to 1 by mu naught E bar del cross B minus E bar epsilon naught rho E by rho T. I found it from Ampere law. Okay, this was the Ampere law. Del cross B is equal to mu naught J plus mu naught epsilon naught rho E by rho T. So I want J no, so I want this only. So mu naught del cross B minus mu naught epsilon rho E by rho T. I transferred mu naught. Okay, mu naught gets cancelled, and I multiplied with E bar on both sides. So I got this equation 7. Now I have to substitute 7 in equation 6. Correct? Yeah, let us do that. Yeah, here I got equation 7 now. In that, what was there? E bar dot del cross B bar was there. So I want to find that value first. I want to find that value, then I will substitute in place of that, and after that I will substitute it in work done place. Okay, work done formula. So first of all, before finding that, I know one trigonometric formula. So like if I want to find, we know that del of A cross C. For example, I have two vectors. Then what I can write? C bar of del cross A bar minus A bar del cross C bar. I can write that. Correct? Yeah. So I will write now del of E bar cross B bar. Then how it can be written? B bar of del cross E bar minus E bar of del cross B bar. Again, so I want here E bar of del cross B bar, E bar of del cross B bar. So I want to write that. So E bar of del cross B bar is equal to B bar of del cross E bar minus del of E bar cross B bar. Correct? So again, I know from Maxwell equations, from Faraday's law. So what I know? Del cross E is equal to rho B by rho T. Okay, now I will substitute that rho B by rho T in the above formula. So what I will get? E bar of del cross B is equal to B bar rho B by rho T minus del of E bar cross B bar. This was minus, so minus and minus, and again, yeah, I got the value of E bar dot. Now I will substitute this formula in that equation, in equation 7. Let us consider this as equation 8. Okay, so 8 in 7. So what I will get? That value J bar dot E bar is equal to 1 by mu naught. So what I got that value? E bar of del cross B bar minus B rho B by rho T minus del of E bar cross B bar minus E bar epsilon naught rho E by rho T. Correct? So I have values like minus B rho B by rho T, minus E rho E by rho T. So like we know we can write those values here, like see, minus B rho B by rho T minus B rho B by rho T can be written as half rho by rho T B square into minus, okay, minus half, like rho by rho B into rho B into rho B by rho T can be written as half into rho by rho T B square, because if differentiation of B square was 2B, 2 gets cancelled, you will get B into rho B by rho T. So like similarly E into rho E by rho T can be written as half rho by rho T of E square, correct. So I will substitute here and here those values. So what I will get, J bar dot E bar is equal to 1 by mu naught minus B rho B by rho T, half rho by rho T B square minus del of E bar cross B bar minus epsilon naught, like half epsilon naught rho by rho T E square. Okay, so again I have to JE I have to substitute here, correct. So after substituting, so I have to substitute here now. Before substituting, what I will consider, I will take like minus 1 by 2 from these two terms. So minus 1 by 2, what I will get, minus 1 by 2 rho by rho T I will take common, minus 1 by 2 rho by rho T, or I can take, I think minus 1 by 2 rho by rho T. So finally what I will get, 1 by mu naught B square. So rho by rho T, 1 by mu naught was constant, so it was differentiation to B square only, 1 by mu naught B square, and here minus I took, no, so plus epsilon naught 1 by 2 minus 1 by 2 rho by rho T I took, epsilon naught E square, okay, 1 by mu naught B square plus epsilon naught E square minus this was 1 by mu naught del of E bar cross B bar. Okay, so now I got J bar dot E bar. So this was value 7, or not 7, like 9. So I have to substitute this 9 in this 6th equation. Okay, this was dW now, so dW I write here. So what I am doing, 9 in 7, dW I write here, J into E d tau dt, no. So J into E, what I got value, this value. So I will write here. So minus 1 by 2 rho by rho T of 1 by mu naught B square plus epsilon naught E square minus 1 by mu naught dou E bar cross B bar up to here, okay, this whole into d tau dt, correct. So I got that value. Now what I am doing, I will multiply whole equation with d tau. So I will transfer dt to left hand side. Okay, I will transfer dt to left hand side. After transferring, dw by dt is equal to minus 1 by 2 rho by rho T 1 by mu naught B square plus epsilon naught E square into d tau minus 1 by mu naught dou E bar cross B bar d tau. This was like integral, volume integral. This was surface integral. That's it. This was the Poynting theorem. Understood? This was the derivation. First I took like applying the formula, work done formula, force into displacement. Force I am applying Lorentz force. Displacement I am applying velocity into time. Distance is equal to speed into time, velocity into time. So in place of force I am applying Lorentz forces like Q into F plus del cross B. In place of displacement, velocity into time. So there is no force due to the magnetic force. So it was equal to 0. Then finally we will get force into that velocity into time. Okay, Q into q into force into velocity into time. So I will apply then charge density formula. What is the charge density? Q is equal to eta into v. Okay, eta into v. So what is the current density? J, current density. J is equal to rho into v. Then what I will get? Rho J by v. I will substitute that rho in the place of here. J by v. V gets cancelled. Then I will get J into E d tau d time. Now after that I will apply the Ampere law, Ampere circuit law. Then after that I will apply trigonometric law. Okay. By that I will found that Ampere law correctly. So I will substitute directly J dot E. So I will get the Poynting theorem. This was the proof for the Poynting theorem. Yeah. Check it. Yeah. Thank you.